So the amplitude of this graph is still that number that's in the front. That's a 2. I like getting the easy things out of the way. Period is the thing I do last generally. My horizontal shift, it's plus, so it goes opposite, which means left. Pi over 3. I go down 4 units. And how do I get period? What's the calculation for period? 2 pi over, in this case 2 pi over 3. So what I'm concerned about and wanted more time is the next page, which takes us to graphs. Take a look at what we now have to do with these graphs, and I've lost my screen settings. So on the graph I have drawn in red what a sine graph should look like. We've recognized that it should have gotten taller. In fact, it should have gotten taller by a factor of 4. So I'm going to make my amplitude 4. The graph should have had a peak at pi over 2. Where is it peaking right now? Where is that? Or my graph should have started at 0, and now it's starting here. What's one box worth on this graph? This analysis is hard, ladies and gentlemen. Just taking a look at my horizontal shift. My horizontal shift, where my graph was supposed to start compared to where it actually starts, is 2 boxes times 2. Horizontal shift, is that A, B, C, or D? It's C. My horizontal shift is C. My horizontal shift is 2 pi over 6. Is that a good way to write it? Pi over 3 is certainly nicer. Is there a D value I have to worry about? Nope. There's no vertical change, so there's no D value. Is there a B value I have to worry about? Well, let's check it out. It doesn't say that there's a B value, but the distance from here all the way to here, what's the period? Can you figure out what the period is? How long does it take to start from 0 and go through a crest and a trough? So I've got the answer as 4 times sine x minus pi over 3. Now I'd like to do the setup for the next one. The setup for the next one is the same graph. It's the exact same graph, but guess what A is? A is less than 0. So if A is less than 0, that means it's negative, and a sine graph that's negative should have done this. So this is what a regular sine graph should have looked like, with a negative out in front. So instead of going up, it went down. I want to see if you can figure out what is my A and C value here. So taking a look at where my graph actually started, and it has to start down. Do I look for a shift to the left or for a shift to the right? My graph has to go down first. Where's the closest down, to the left or the right? The closest down is to the right? That's way over here. I think the closest down is looking this way. I'll let you study that in a minute. Each box is worth pi over 6, and I shifted over 1, 2, 3, 4 boxes. So I have to times my shift by 4. So my shift is 4 pi over 6, and it's shifting to the left. So is that a positive or a negative value? I'm shifting to the left. Is C positive or negative? Remember, it's opposite. Shifting to the left is like adding. And would you make it 4 pi over 6, or would you change it? 2 pi over 3, awesome. 2 pi over 3. So this graph gets written as y equals -4 sine x plus 2 pi over 3. We need to get very good at looking at those shifts. The next graph is a cosine graph. It's a little different, but the work is going to be the same. I'll put on the original cosine graph in case you don't know what it is. And then we're looking for the A and the C value. So this graph has the same value, same scale value along the x-axis. I have pi over 2 cut into 3. So each box is worth pi over 6. And how many boxes did I shift over? I shifted over 1, 2, 3, 4. I shifted over 5 boxes. I shifted to the right 5 boxes. So I've got a 5 pi over 6 shift. Because I shifted to the right, is that positive or negative? It's negative. My C value is minus 5 pi over 6. And I get to write my cosine statement. So this is a graph of y equals 4 cosine x minus 5 pi over 6. If I would keep the 5 pi with me. Minus 5 pi over 6. Put that in brackets. Okay, can you try the D1? The D1 is similar to what we've seen, except now I want it with a negative A value. So I'm going to flip the cosine graph around and then have you look at it. So taking a look at this graph, I want to look for the closest spot where I have a start that resembles what the graph is supposed to do. That is, start low and then move high. So that starting low spot is actually over here. I've shifted to the left, which already gives me an idea that my shift to the left is a positive value. And it's only 1 box over. What's 1 box worth? Pi over 6. That's awesome. This is a graph of y equals minus 4 times cosine of x minus pi over 6. Just take a note, it should be y equals minus 4 cosine x plus pi over 6 because I shifted to the left. The graph used to be situated around the x-axis, but now I can see that it's moved down 2 units. So my vertical displacement is down 2. What's my amplitude? You already told me, right? What is that? That's 3. Awesome. So I have an amplitude of 3. We want to look at the horizontal phase shift next. So taking a look at where my graph starts, my graph should have started on the axis, but it started 1 box over. What's 1 box worth? It looks like my pi value in that first scale derivation has been cut by 3. So every box is worth pi over 3. And I have a horizontal shift that is pi over 3 to the left. Is that a positive pi over 3 or a negative pi over 3? Positive or negative, because I moved left? Yeah, I'm going to there. So my horizontal shift is pi over 3. Can you do the period part for me? Just looking at my period calculation, my period is 4 pi. What's the b value that will make this true? Mathematically, how do you do that? Yeah, 1/2. Mathematically, the b moves up and the 4 pi moves down. So b is 2 pi over 4 pi. My pi's cancel, and 2 over 4 is a half. So my b value is a half. So we've got an equation. If this is supposed to be sine, it looks like this. Y equals 3 times sine. My b value is next, a half. Then I have brackets. I have my horizontal shift and the sine included already. X plus pi over 3. And then I went down 2. I actually like you guys to try some of the exercises. We're missing alignment for right now. We've got a nice 45-minute chunk of time. Can you try out our skills on our assignment?